All right, section 11.4 continues on with compound events. Now, we just got done looking at a couple of compound events that were called independent and dependent events. And what I put together for you here is a chart of all the compound probability situations that you may encounter. So you may want to pause the video and copy down this handy flow chart. First of all, there's two types of compound probability situations. Those that deal with the word and, which is what we talked about in the video on section 11.3, which is this stuff. Independent events and dependent events use the word and we all remember that and means multiply. What we're going to look at in the next two videos here in section 11.4 are compound events that use the word or. The word or indicates addition. When you have a probability situation with the word or, you add. Now there are two terms that go along with the word or. If you have an or problem, it could be a mutually exclusive situation or it could be an inclusive situation. This video will deal with mutually exclusive. Video number 2 in section 11.4 will be about inclusive. Now down at the bottom, which is going to be very helpful, is for you to understand how Venn diagrams are used in these situations. First of all, if you have a mutually exclusive event, there will be nothing in the intersection area of the two circles, right in there. There won't be any outcomes. However, if you do have an inclusive situation, in the shaded area in green, you will have at least one outcome in that intersection. So make sure you understand that, and we'll talk about that as we go through this video. All right. We have an or problem in front of us, the word or. How do you decide if it's mutually exclusive or if it's inclusive? You have one key question that you have to ask yourself. Can the events or situations that are described, that are given, can they happen at the same time? If the answer to that question is no, then it is mutually exclusive. Now, what does mutually exclusive means? Mutually exclusive is two or more events that can't, write that in capital letters, can't happen at the same time. Can't. What else does that mean? Well, if they can't happen at the same time, that means they have no outcomes in common. Obviously, there will be nothing in the intersection. Nothing in the intersection of the Venn diagram, just like we had on the prior slide. Now, if it's yes, then that's inclusive, which we'll talk about in the next video. But I want to look at a couple of examples of what mutually exclusive means. All right. You have one die in your hand, and you roll it. I want to know, what is the probability that when you roll that die, you get a 5, or, there's the key word, you get an even number. So the first thing you have to do is ask yourself the key question. I'll go back a slide. Can the events or situations that are given happen at the same time? Can I get both a 5 and an even number if I roll one time? The answer to that question is no. You cannot get both. So therefore, what type of problem is this? It is mutually exclusive. All right, now, let's draw a Venn diagram. I'm going to show you how to draw a Venn diagram for this situation. I'm going to do a little erasing here. All right, we have two ovals because we have two situations here. And we're going to label the ovals. Number one, you could get 5. So we're going to list all the 5s on a die over here. The other situation is it could be an even number. So the second circle I'm going to label as the even numbers. Now, when you roll a die, what could you get? Well, you could get a 1. Where does the 1 go? Well, 1's not a 5, and it's not even, so the 1 would go on the outside. How about a 2? Well, a 2 is an even number, so it would go there. How about a 3? 3 is not a 5, and it's not even, so that would go on the outside. 4. A 4 is an even number. That's good. A 5. Well, 5 is a 5. It's not an even number, so it'll go there. And 6. 6 is not a 5, but it is even, so it would go in there. Now, if you notice, I'm going to outline in black, the intersection of the two circles, there is nothing in there. That is what mutually exclusive means. There is nothing in that intersection point. All right, well, let's solve the problem. I want to know, what is the probability of this outcome? What is the probability that I get a 5 or an even number? Well, what that means mathematically, this is equal to the probability I get a 5, and the word or, I said on the prior slide, means addition. So the probability I get a 5 plus the probability that I get an even number. All right, well, what is that? Well, the probability I roll a 5, we all know that's 1 out of 6, plus the probability I get an even number. Well, there are 3 even numbers out of 6, the 2, 4, 6, which is equal to a 4/6 chance, or which reduces to 2/3. That is the probability of this certain event happening. Now, if I was going to summarize this mathematically, the word or means union. And the union symbol is a U in mathematics. So, the probability of event A union B, like I have right here. I have probability 5 or an even number is equal to the probability of event A happening plus the probability of event B happening. It's the union of both. So kind of get used to that notation because you will see the union symbol associated with the word or. All right, one more. A group of students is donating blood. Any particular student has a 1/4 probability of having blood type O, a 2/5 probability of blood type A, and a 3/20 probability of blood type B. Down at the bottom is the question. What is the probability a student chosen at random has blood type B or blood type O? Well, the first question is the key question. For what type of problem? The key question. Can both events happen at the same time? Can you have both blood type B and blood type O? Well, obviously that answer is no. So therefore, what we have in front of us is mutually exclusive events. All right. Now, Venn diagram. There are 3 blood types. We're going to call, so when you draw 3 circles, it's got to look like this. This would be blood type A. This could be labeled blood type B, and this could be labeled blood type O. Well, obviously, there can be nothing in the intersections. What's the probability of having blood type O? This is 1/4. Probability of having blood type B, that's 3/20. And the probability of having blood type A is 2/5. So, what is the solution? The probability that I have blood type B or blood type O, since they're mutually exclusive, is the probability of blood type B plus the probability of blood type O. So, probability of blood type B is 3 out of 20 plus the probability of blood type O, which is 1/4. And if I change that to a fraction with 20 in the bottom, that would be 5. So therefore, I have a total probability of having blood type B or O 8/20, which reduces to 2/5. And that's the probability that will answer my question. And people, that's how you do mutually exclusive events. And the key is you cannot have the two events happen at the same time.